Hi everyone. So today we're going to focus on identifying the vertical and horizontal asymptotes. Now, in a way you already have been doing this because they have to deal with the transformations. So for example, I'm going back to the very first problem we did on Monday, our parent function 1 divided by x. Now my horizontal asymptote was y equals 0. So remember, it's that imaginary line that your function gets really, really close to, but does not actually touch. And then my vertical asymptote was x equals 0. Because a vertical line always goes up and down. When you think about like your vertical leap or your vertical jump, it's how high you can jump up and down. And then horizontal asymptote is like the horizon. It goes across. So my vertical asymptote, again, in this one would be x equals 0. So it's that line you can see my function gets really, really close to, but never actually crosses. Now, for our parent function, it just defaults to y equals 0 and x equals 0. But we need to figure out how does that change if I start to shift these functions. So I have a few examples towards the end here. So the first one is 4 divided by x minus 1 plus 2. Now, what I would recommend doing is graphing these in Desmos, and I'll show you how to do that in just a few minutes, but I've actually pulled up the graph. So before we get to the graph, let's talk about the transformations. So over the past 2 days, you've been practicing identifying the transformations. So in the numerator, because we see this 4 here, that tells us that there's going to be a vertical stretch. Then in the denominator, I see this x minus 1. So that's my horizontal shift to either left or right. And remember, it's always opposite. So this would be an example of moving right 1. And then this plus 2 tacked on at the very end means my graph is going to move up 2. So I'll show you what this graph looks like. So here's my graph, 4 divided by x minus 1 plus 2. And I'm going to actually draw in those asymptotes so that we can see them a little bit better. So if you look for our horizontal asymptote, there's a break in our graph right here. So that's where I'm going to put my dotted line. And especially on the left and right hand side, you can see kind of how my function is getting really, really close to that line, but will not actually touch. And that line appears at 2. So this would be y equals 2 is my horizontal asymptote. Then I have another one, a vertical asymptote. So again, that's where you see this break in the graph here. So if I draw a dotted line down here, so that vertical line represents my vertical asymptote. And now I want to make sure that I drew it right in the middle of those two curves. And then to identify it, I look to see where I drew that line. It looks like it's at about 1. So my vertical asymptote would be x equals 1. Now, that corresponds with our transformations. So if you can remember here, we moved right 1 and up 2. That means my asymptotes also move right 1 to positive 1 and up 2 to y equals 2. So then to write these asymptotes, for my vertical asymptote, because it's a vertical line, remember vux, it's always x equals. So I would write x equals 1. Then for my horizontal asymptote, it's a horizontal line. So we have hoi, horizontal line, y equals. So I would write y equals 2. Now my domain is going to correspond directly with my vertical asymptote. So if I look back at that graph, you can see looking left and right, my graph goes, takes a break at x equals 1, and then picks up right back on the other side of that vertical asymptote. So that means that my domain would be written as negative infinity to 1, union 1 to infinity. So this union means bringing together two parts. So I have my break at 1, and that's why I put the union symbol there. Likewise, my range corresponds with the horizontal asymptote. So it would be negative infinity to 2, union 2 to infinity. Again, if I go back to the graph, You can see looking up and down starting from the bottom, my graph goes up, 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 takes a break at that asymptote and picks up right back on the other side. That's all we're going to focus on for today. So let's look at another example or two. So for number 11, I have negative 1 divided by x minus 4 minus 3. So that negative symbol tells me that there will be a reflection. Because I have x minus 4 in the denominator, I know I'm moving right 4. And then this minus 3 tells me I'm going to move down 3. So in order to graph this on Desmos for you to see a better picture, I'm going to pull Desmos up. So I would do negative 1 divided by x minus 4 and then minus 3. So this might help you also to get a graphical display of these functions. So that way you can look for your horizontal asymptote. So it's going to be right in the middle of those two functions. So if this is negative 2, here's down negative 4, it looks like my horizontal asymptote is at negative 3. Likewise for my vertical asymptote going up and down, so you can kind of see this break here at positive 4. So that means it would be at positive 4. So going back to jot these down, so my vertical asymptote is going to be x equals 4. Note it comes from that horizontal shift, so it's just the opposite of what you see in the denominator. And then my horizontal asymptote is y equals negative 3. And that comes directly from that value at the end. So then going to my domain and range. My domain comes from our vertical asymptote, so negative infinity, comma 4, union 4, comma infinity. Likewise, my range comes from the horizontal asymptote, negative infinity to negative 3, union negative 3 to infinity. Okay, why don't we do one more, and then I'll have you do the last one on your own. So looking at number 12, I have 2 divided by x plus 1 minus 4. So I can see here that I'm going to have a vertical stretch. My function is being moved to the left 1 and then down 4. So because my entire function is being moved left 1, that means my vertical asymptote is going to be x equals negative 1. It's opposite. Then my domain would be negative infinity to negative 1, union negative 1 to infinity. My horizontal asymptote comes from that up or down movement. So since I move down 4, my horizontal asymptote is y equals negative 4. And then my range would be negative infinity to negative 4, union negative 4 to infinity. And remember, it helps to graph these on Desmos as well. So I could always go back into my graph. I'm going to get rid of this function and change this to 2 divided by x plus 1 minus 4. And here I can see that I have that vertical asymptote or kind of break in my graph at negative 1. I have that horizontal asymptote at negative 4. And my domain, so coming from the left, it moves to the right, goes, takes a break at that vertical asymptote and picks up right back on the other side. Same thing with my range moving up and down. So it comes up from the bottom there, takes a break at negative 4, picks right back up on the other side. Okay, before you take the quiz, I'm just going to ask then that you do the last problem, number 13. So I'll show that to you right here. And just make sure that you can identify both the vertical, horizontal asymptote, vertical, horizontal asymptote, and domain and range. We're going to be skipping the reflected and the y-intercept for right now.